They are the most spectacular of igneous rocks. Batholiths are very spectacular, and they have a very large mass, and they may be exposed as a result of derivation, which we have talked about earlier. And batholith forms longitudinal ridges in fold mountains. This is a very good illustration or diagram of intrusive landforms. If you look carefully, you will see the dikes, you will see the seals, and you see the batholiths at the base here, and the other intrusive landforms. Now, let us also look at effects of volcanicity. When volcanicity or when volcanic activities take place, do we have certain effects which are being felt by man, the environment, land, animals, even plants? Let's look at them now. There is ejection of what we call hot lava and ashes and other materials. When we have volcanicity, there is ejection of lava. Now, lava is magma that has reached the surface. So when magma is erupting, or when it erupts and gets to the surface and begins to flow, it is no longer magma, but it is lava. So one effect is ejection of hot lava and ashes. Number two, it increases the surrounding temperature. You cannot imagine the degree of temperature of this magma. It is so hot that surrounding lights are consumed by the heat of the heat coming out, or the heat associated with the flowing magma or lava. Now, when this happens, there is also displacement or submergence of settlement. This may automatically lead to the destruction of the structure, because it may lead to total collapse of that structure or that building. Now, that's what we call destruction of lives and properties. Definitely, when this happens, if it happens in an area where we have human beings around, there's bound to be large-scale destruction of lives. So this is an effect. And it also leads to air pollution, water pollution, and it has tendency to cause flood and landslide. However, this effect, the last effect I have here, is an advantage because of the rich or the abundance of minerals in these molten rocks. When they flow to the surface, it leads to formation of fertile soil for agricultural activities. So those are the effects of volcanicity. Now let us look at extrusive landforms. Extrusive landforms, these are landforms that result from the eruption of magma that has gotten to the surface and has cooled and solidified. Now, when magma gets to the surface of the earth, like I said before, it is termed lava. And magma gets to the surface either through a hole, which is called vents, or through cracks, also called fissures. Some extrusive landforms we have here include composite cones, lava cones, or lava domes. Now let's talk more about the composite cones. The composite cone has the following characteristics. It has highest form of volcanoes. It is the most common type of volcano. The lava cone or the composite cone is conical in shape, just as the name implies. And it is made up of alternate layers of ash and lava. That's to say, when you have ash on top, the next layer will be lava, and the sequence continues like that. And Examples of composite cones include the Mount Fuji and the Vesuvius. This is what we have been talking about, the composite cone. You can see the conical nature of the whole feature or landform. And you can see vents, that's the holes or openings through which this lava can come out to the surface and give rise to the various landforms. Now let's look at lava domes. Lava domes can also be called shield volcanoes. Have gently rising slopes and broad flattened top, and they are formed from basic lava. The top landform, exclusive landform we have here is ash and cinder cones. Now, ash and cinder cones are formed from less fluid acid lava. And when the crater, okay, now let's consider what a crater is before we can now begin to talk a little about it. A crater here is just a depression on top of the cone. And so when this crater becomes an enlarged depression, it is called caldera. And in another case, when we have water occupying the crater, we call it a crater lake. So this is what the lava dome looks like. You can see the red color there, that's magma, very hot, probably on its way to get to the surface, and as it continues, it gives rise to lava dome. There are types of volcanoes which we are going to consider briefly. We have three of them. One, we have the active volcanoes. Two, we have the dormant volcanoes. And finally, we have the extinct volcanoes. And all these three got these names as a result of their characteristics and behaviors. Now, the active volcanoes, they are known for their frequent eruptions, mostly in their early stage. So an example of active volcano is the Cameroon Mountain, which has erupted 4 times within a period of 50 years. Now, a dormant volcano, as the name implies, is known to have erupted and have also shown signs of possible eruption in the future. So that makes it dormant. The potential is there. It has erupted, although it has stayed long and there have not been occurrences of eruption, but the signs are there that it may erupt in future. Whereas the extinct volcanoes, they have not erupted at all in historic times. So these are the 3 types of volcanoes that we have. Let's talk about the karst or limestone topography or limestone region. Limestone or karst topography region refers to a large area of land occupied by limestone which possesses a unique topography. Limestone is a sedimentary rock of organic materials made up of calcium carbonate. Now, the limestone region has the following characteristics. One, we have solubility. Though a limestone region is insoluble, it is made soluble by the action of rainwater. 2, the presence of depressions. Limestone region contains depressions of varying sizes and depths. 3, there is absence of luxuriant vegetation cover in limestone region. 4, we have that the presence or absence of surface drainage. Now, due to the easy permeability of the region, most surface water flow for short distances. Now, there is presence of joints and rugged topography. Also, there is presence of dry surface valley, and this is due to the penetration of water in the region. Here is a diagram showing us what a limestone or karst region looks like. You can see the caves, the springs, and the guides, all features of the limestone region. The limestone region has surface features and it also has underground features. Let us talk about some of the surface features. Number one, we have the grades. Grades are formed as a result of the progressive widening of cracks or joints by solutions in order to form limestone pavements. Number two, we have the cleats. These are rectangular blocks between joints or grades. Number three, we have sinkholes. Sinkholes are small depressions carved out by solution where rainwater sinks into the limestone at a point of weakness. Those lines are formed when several sinkholes join together to form a larger depression. Uvara here is formed when several dough lines join together to form a larger depression. Finally, we have the poges. Poges